A very good day to you all. I want to use this medium to review some of the questions we had during our physics quiz. I discovered that some of us had issues with some questions, and I'm taking this time rather to review those questions. The first question talks about which of the following are derived. 1 meter, 2 coulomb, kilogram, ampere, and joule. You can see meter is a fundamental unit of length. Coulomb is a derived unit of charge. Kilogram is a fundamental unit of mass. Ampere is a fundamental unit of electric current, and joule is a derived unit of work or energy. So looking at that, we can see that it's 2 and 5. That is the right answer. Number 4. So I want to apologize on this number 4 because there is a slight typographical error. It's supposed to be ml squared t minus 2, though the concept of the question is not yet disproved, because I want you to understand that how you handle this question matters. You could have seen that there is one slight alteration in the sign. Now look at this particular write-up. The ml squared t minus 2. Splitting this down, we have this to be ml. I want to take 1t here, 1t here, 1l here, 1t here. Sorry, t, this 1l here with this factor t minus t raised to power minus 2. So we have l t raised to power minus 2, and the remaining l here is the one that we have here. Now, if you look at this m stands for mass. Yes, according to the transformation, when you are talking about the dimension, lt square minus, that is lt raised to power minus 2, is the acceleration. That is unit of acceleration, the dimension of acceleration. While L is that of the distance or the length or altitude or just any parameter that has the same unit as length. Looking at these two together, we see that mass, this is mass by acceleration, and this is time, is distance. Looking at this concept, mass by acceleration is force. Why the distance is? So this is force by distance. By the time we transform this, the dimension rather, we could say that it ends up in force by distance. And if we look at the quantity given to us, we could say that it's only torque and energy. Torque is force by length, while the energy is force by distance. So the correct answer to that is 2 and 3. That is D, 2 and 3. Next question, the watt is equivalent to the formula for watt. Wattage is the unit of power, and power, I'm talking about mechanical power now. Mechanical power is the work done over time. Let's look at this, the work done over time. That is power. Excuse me. Yeah, this is it. Now, watt is joule, that is from work done or energy expended over time. That is why we have this joule per second or Newton meter per second. Don't forget that a joule is a Newton meter, force by distance. So power is energy over time. So if you look at the dimension of energy is ml squared t minus 2. That is what we have in question 4 above. So over time. So by the time you take this using indices, we have this to be ml squared. When this t come up, t becomes t raised to power minus 1. So because minus 1 minus 2, so we have ml squared t minus 3. That is the dimension of power, and that is for watts, which is the unit of power. So we have A to be the correct option there. The next question is a boy walks 10 meters due east and then 10 meters due south. We are looking for the displacement. Now, some of you, I don't know why some of you are getting 60 degrees. because I don't think there's anything given to you here to get 60 degrees. So let's look at this together. The boy walks from 10 kilometer east. That is the first one. 10 kilometer east. Let's say this is 4 cardinal point. Let's say this is where the boy stand. This is north. Let's say this is north. This is the north. So 10 kilometer here, 10 kilometer here. That is so south. When they get to the east, this is the east. It get to south, and this. They now say what is the displacement from the starting point? That is this x. You look at this, that this is more or less an isosceles right angle triangle. Isosceles. So if you apply Pythagoras theorem, you will get this one to be 200. That's what I work at, 200. That is 200, root of 200, which is 10 root 2. So this is 10 root 2, which is x. So that means if you are to look at this is 45, because if this is isosceles right angle triangle, this is 45, this is 45. So the answer is going to be 10 root 2 meters in the south, 45 degree east. That is about that. Now, the next question is talking about a body initially at rest at acceleration under a constant force of 50 Newton at the rate of 0.2. We are given 0.2 meter per second square for 5 seconds, which means now initially at rest actually means that the body is starting or has initial velocity of 0, u equal to 0. Our acceleration is 0.2 meter per second squared. The time has been given to be 5 seconds. And we are given the force. The question asks us to find the what? What's the corresponding? The work done. What is the work done? The work done is force by perpendicular distance. Force by perpendicular distance. That's the work done. Now look at this now. We are giving U, F, A, U, F, A, T. The work done is force by distance. Can you see that? So force has been given from the question 50. Distance is 2.5. How do we get that? The distance using one of the equations of motion says that distance equals to ut plus half at squared. You are given u 0, t, this is 0, plus half by a is 0.2, and t squared 5 squared. So that means our s is 2.5 meter. So work done therefore is force, which is 50 by 2.5 meter, which is 125 joules, which makes the option C to be correct there. Which of the following is a set of vectors? Look at this. Some of you got, except one person that pick mass, force, and impulse. Velocity, volume, and upthrust is never, because they are not all true vectors. Volume is not a vector quantity. Volume is a scalar quantity. Upthrust. Now look at this now. Density, capacitance, and distance. Here is only density. Distance here, the distance is a scalar quantity. So automatically that option is wrong. Here mass is a scalar. So automatically everything, because they said all set of vectors. So look at the option, which is the D. Weight, displacement, and moment. They are all set of vectors. Next question. A spiral spring extend by 5 meters under a load. Now, we are given a spiral spring. The extension here, this 5 is the extension, and 60 degree is the load, which is the, so this is supposed to be Newton, 60 Newton, a load of 60 Newton. When the load is replaced by a steel block, the new extension is, look at this, I put this into writing. Let's look at this together. Now, the force constant of that force spring given to you, the force constant is F over E. That is according to the Hooke's law. And you are given the force to be 60, and the extension by which is extended is 5. So that means the force constant there will be 12 Newton per centimeter. They now say, what is the weight of the steel block? Now, we already know that they gave us the extension of that new steel block to be 7. And we have gotten the K, which is the force constant of that, because it's still the same material being used. Look at the question. A spiral spring, is still the same spring? So the force constant of the spring, because the spring that carries that has a section of 5 also has 7, is 12 from this. So that's why we have 12 times 7. So the weight of the steel is now 84 Newton, and that's exactly why we see rather is right. The temperature 45 degrees here, we have to convert 45 degrees centigrade to Fahrenheit using the standard scale. We have this. Now, if you are converting 45 degrees, if you convert, it is 113 Fahrenheit. How? In Celsius scale, we have 0 as the minimum, 100 as the maximum. In Fahrenheit scale, we have 32 as the minimum, we have 212 as the maximum. So by the time you have 45 minus 0, which is this, over 100 minus 0, which is this, equals to F minus 32, which is this, over 212 minus 32. 212 minus 32 is 180. So by the time you solve for your F there, you get 113 degree Fahrenheit as a question. The equation below uses Boyle's law to now. In Boyle's law talks about the pressure PV equals constant. That is pressure volume equals constant. So by the time you can see the temperature here in this formula is 0 because it doesn't have any temperature parameter at all. So the temperature is assumed to 0 because anything is over 0 is 1. So we have A equals to 1, B equals to 1, C equals to... There's a typographical error in that question as well because it's supposed to be 110, not 011. But the idea of the question is what I am trying to test you upon. So the next question, the next question is, which of the following substance is not an insulator? Everybody should know that silver is a conductor. Silver is a conductor. It's one of the elements that conduct most in out of the elements that we have. In which of the following states will the average speed of the molecules of water be highest? I want to tell you that average speed increases when there is increase in temperature. So water has its maximum temperature at steam level, which is 100 degrees centigrade. So at steam level, water average speed of the molecule, because speed of the molecules increases with temperature. So the speed will be highest at steam level, which is D. Temperature is the property of a body which is proportional to the temperature is always proportional to the average kinetic energy. That is the molecular definition. Molecular theory definition of temperature is the measure of average kinetic energy of the molecules of a substance. So the option B there is very, very correct. The 15, the length of a wire of temperature minus 10 Celsius of a telegraph wire of length. So they gave us length. Now the length is 100 meters. That's the original length. The set temperature is minus 10, and at 30 degrees has a linear exponential of 2 exponential 5. The question says we should find the length after it has expanded. That is the length. Let's look at this together as well. Now, the formula for linear exponential is talk about the alpha equals to delta L over L1 delta theta. And when we make the delta L, so a formula here, we have delta L equals to, we have alpha L1 delta, and we are given alpha, which is the linear expansion of that substance. You are given the original layer, which is 100, and the change in temperature, they say, is from minus 10 to 30. So that means theta 2, this is theta 2 minus theta 1. So by the time you get that, you get our delta L. What's the changes in length to be minus 8 exponential minus 2. So the question says we should find the change. We want to get the final length that thing, that particular material expanded to. The final length is the original length plus the change. And we have gotten the change to be, this formula is gotten from delta L. It's gotten from delta L equals to L final minus L initial. So that is 100 because that's the initial minus the change. So that gives us 99.92 as the answer there, which is option D. A man runs a distance of 1 kilometer in 5 minutes. The average speed is, this is very simple. Just try and convert the 1 kilometer to, because if you look at that, you see that the unit of 1 kilometer was given in kilometer, and the time they said 5 minutes is also given in minutes, but the answers, the options of those questions are given in meter per second. So which actually means you need to convert this one to meters, which is 1000 meter, and this is 5 by 60 seconds, which is 300 seconds. So the speed there is distance over time, which is 1000 over 300, and that one will give you the 3.3 of a thing that we got there. That's 3.3 meter per second as the answer. A body accelerates uniformly from rest at 3 meter per second. It rests after traveling a distance of 24 meter. In that question, you are given some parameters which I want you to try and look at. Look at the parameters given to you. You are given. They said the body starts from rest, which actually means that U equals 0. They give us acceleration to be 3 meter per second squared. You are given distance to be 24. The question says we should find the velocity. Using the formula V squared equals to U squared plus 2AS, we get this because it's already 0 plus 2 by, what is our A? 3 was our S, 24. You get this one to be 144, and this V squared, this is V squared, and V will be square root of 144, which is 12. That's how we got this to be 12 meter per second. Now the unit of momentum is kilogram, that is mass by velocity, which is kilogram meter per second, or the same unit as the impulse, which is the force times time, Newton seconds. So we have Newton seconds or kilogram meter per second. So option B there is the correct one. The 70 kg man assigned a flight of stairs of height 4 meter in 7 seconds. The power. There you are given some parameters as well. But what is the work done? Because power is the work done over time. The work done in that question, you will be given the work done indirectly. And how do we do that? Excuse me. Now, if you look at that question, the work done is mgh. You are given the mass, which is 60, the gravity acceleration is gravitation, which is 10, and the height to be 5. By the time you have the work done here is equals to 2,800. That's the work done. So by the time we now say power is the work done over time, so that is 2,800, and you are given the time from the question is 7. So this actually gives you 400 watts as the answer. Now the next question is at which of the following temperatures will a given mass of water occupy the greatest volume? Water has the maximum volume at 100 degrees centigrade. That's what we explain under the anomalous behavior of water. It has a minimum volume of at 4. It has a maximum density at 4 degrees centigrade. It has a minimum density at 100 degrees centigrade. So the answer here is 100, which is option D. A spring balance. The spring balance measure mass. Spring balance does not measure mass here. I want you to take note. Spring balance does not measure mass. It actually measures the weight, and weight is the earth gravitational pull on a body. So that's why 2 is correct, and 3 is also correct. The weight of a body on ground. The 2 and 3 are the same thing because the weight is earth gravitational effect of earth gravitational pull on a body. So 2 and 3 are correct in that particular question. 22, which is the last question, let's talk about The automobile or speed of 20 meters per second is brought to a halt. The word brought to a halt means that the final velocity there is 0. The force is 5 kilonewton, which is 5,000 Newton, and we have time to be 10 seconds. The question says we should find the mass of the automobile. Quickly, we can talk about the acceleration based on that question. Acceleration is V minus U over T. Don't forget that they say it's brought to halt, so making V to be 0 minus, we will be given the initial velocity to be 20 and the time there is 10. So acceleration here is minus 2 meters per second. This negative sign means that body is not accelerating, it's decelerating. So the question says we should now find the mass. Mass is force over acceleration from F equals to ma. So this is 5,000 over acceleration is 2. I'm not 2. So I'm taking 2 because that's the magnitude. The negative means that it means the direction, which is actually means that it's decelerating. So the mass thereafter becomes 250 kilogram, which makes the option D to be correct. Here is the review of all the 22 questions that are set. I want you to still look at them, try and ask any question in case if you have any of the explanations not clear. Thank you very much and good day to every one of you. Stay safe.